Hi, good morning, good afternoon, good evening, wherever you are. Welcome to this webinar on blockchain solutions for the enterprise. I'm Satish Babu, President of InApp, and I'll be taking you through this webinar. I've been involved with cryptocurrencies since 2013, and I'm a member of the UN IGF's Dynamic Coalition on Blockchain and also the Internet Society's SIG on blockchain. And I'm currently leading the blockchain initiative of InApp. And one of the things I'm looking at is, apart from the business uses of the blockchain, the use of blockchain for social purposes. So here is the overview of this webinar. I'll be walking you through the introduction. Then on the topic of blockchain integration or retrofitting existing applications with blockchain. And then we will have a short Q&A. So I'll be speaking for about 20 minutes and then taking questions for about 10 minutes. So please note down your questions and you can either type them into the chat or speak as you wish. So we start off by looking at the question of what is really distributed ledger technologies, or commonly known as the blockchain. The blockchain is simply a new way of immutably recording information. And the immutability is maintained by both cryptographic controls and by having multiple decentralized copies of the same information. Now, the building blocks of DLT, be it cryptography or otherwise, are not really new, but the way DLTs have been harnessed in the business environment is actually quite new. And it actually follows the Bitcoin, which came up in 2009 as the first successful peer-to-peer decentralized cryptocurrency. The blockchain actually was the underlying bookkeeping mechanism for the Bitcoin. Today, the DLT and blockchain technologies have emerged as an innovation that's useful for a broad spectrum of uses, ranging from fintech, which is the most obvious use, to enterprise, government, and even social uses. Now, where can you deploy, where can you deploy DLTs? The typical use case is as follows. Known or unknown parties have to work with each other. These could be your friends or your enemies, or you may not know anything about them at all. When such parties have to work together, and each party has to write information and read information into the backing store, the situation normally is that the parties are forced to trust the application and its owner, whoever is running the application. If they have to work together, they have to trust the application. The trust is actually kind of forced on them. Now, that is in the traditional RDBMS approach. However, if you introduce a blockchain there, given the immutability of the blockchain, we don't have to anymore enforce trust through just being forced to trust each other, but the blockchain itself will take care of the trust angle. This is often stated as trust the application and not its owner. So the owner can be taken out of the equation altogether, and the trust is implicit when you use the blockchain. And once you have the blockchain, it can be progressively used for storing information on transactions for assets. Finally, to a point where you can actually store assets themselves. So if you have a physical asset, like a car or an apartment, you can actually convert that into a digital asset. And given the immutability of the blockchain, you can use them, use the physical representation as the asset itself. Now, where and why should you retrofit existing traditional applications? Traditional would mean RDBMS-based applications with the blockchain. First of all, not all existing applications need the blockchain, but nor do they benefit from it. However, in cases that you can really use the blockchain, applications actually benefit from the enhanced trust, transparency, and the reduced cost of enforcing trust. Now, trust usually has a cost. Now, when a firm has accounts with a bank, and the firm does transactions, it does its own recording, and it maintains its own version of truth. But the bank, for the same firm, has another version of the truth. To reconcile these two, you need to have a reconciliation process or an audit, and this costs both time and money. If you had a blockchain in that equation, then the cost of the trust would become trivial because the blockchain would have no real need for reconciliation. We now move on to the technologies that are available currently. There are two kinds of mainstream technologies available today for the blockchain in enterprises. These are called as the permissionless and permissioned. The permissionless version of the blockchain refers to open blockchain networks like Bitcoin or Ethereum, where all peers are equal. Anybody can enter and exit the network at any point. All transactions are usually public, although the parties may not be public. The visibility is usually for all transactions in the public space. Now, the permissioned blockchain is a different creature altogether. It is a blockchain, but here the participants require some kind of an identification certificate. This means that they have to be first admitted through a process to join the network. Now, the participants in the network do not necessarily participate in every transaction, nor are transactions visible to them, unless they are explicitly permitted to join these transactions. The network itself is in most cases private, and it is not affected by the non-core activities that might happen to open networks. For example, a couple of months back, there was a big bunch of computing happening because of a CryptoKitties game. Now, this is a known core activity for most people, but if you're on the open network, how people use the network for this game will decide what kind of a throughput or response you get from the network. Now, that problem does not exist in permissioned networks because only those applications that you provide for will run. Every entity can be given explicit privileges in a permission network. And once the network is set up, there is a cost to that, which has to be borne by somebody. But once you do that, there is no per transaction cost typically. Whereas in the permissionless open networks, there is a per transaction fee. So that doesn't exist in most of the permission networks. So we'll be talking in the next couple of slides about HyperLedger Fabric. Fabric is the one of the foremost platforms available today, which is a permissioned kind of a blockchain platform. It is a distributed ledger solution underpinned by a modular architecture, and IBM claims that it provides a great deal of confidentiality, resiliency, flexibility, and scalability. The last one is particularly important because one of the bottlenecks that exists for the open networks like Bitcoin or Ethereum is that it is not really scalable. Scalability is still a difficult part of the open networks. But the HyperLedger Fabric and similar networks do not have a bottleneck vis-a-vis scalability. It has been introduced and maintained even now by IBM. It had joined the HyperLedger family of blockchain under the Linux Foundation, and today, together with a bunch of other products like Sawtooth Lake and others, HyperLedger is part of the, Fabric is part of the HyperLedger family of products. Fabric provides for a permission blockchain with plug-in consensus modules. Now, consensus is the heart of immutability. It is, in fact, the cost of immutability, the consensus protocol. The Fabric provides for multiple ways to do the consensus process. It provides transaction level granularity, and The scalability is ensured by this process, which I'm not going to get into details, except to state that the whole world is now concerned about the proof of work protocol, which is the consensus mechanism for the Bitcoin, because it is burning up so much of energy. In the case of Fabric, there is no such proof of work, and the consensus is very, very fast. That is the reason for the scalability, the high scalability of Fabric. You can also implement smart contracts, which are automated, blocks of code that execute using chain code. The APIs are available in Node and Go and Java. There is the concept of channel. A channel is an explicit construct that you make to define a particular transaction. So you can identify which nodes are a part of the channel, and only they are allowed permission to participate in that channel. No other node can see any transactions happening in this channel. And finally, Fabric has an end-to-end development ecosystem with a bunch of tools which are quite user-friendly. Now, there is the complexity of a blockchain such as Fabric is non-trivial. I would say the complexity is moderate to high. So the existence of tools is very important. And according to IBM, there are already more than 400 client engagements. And finally, we come to the integration per se. If I have an existing application, how do I integrate with the blockchain? The first part is a system study, which includes feasibility and prototyping if required, and the creation of a minimum viable product, MVP. Now these are, so a team has to look at the existing application and ask questions as to why the owners want to retrofit the blockchain. Once there are clear answers for these questions, and you do a prototype or an MVP, and we have positive response to that, we can go ahead with the next phase of designing the actual blockchain required for this. Now, a blockchain has a number of collaborating peers of various kinds. There is the validating peer, the endorsing peer, and the ordering peer, the certifying authority. So there are various roles that are very important in the case of blockchain. And the team has to look at what is the resiliency, what is the load required, what is the uptime required. And these are the factors that are considered for the design of the blockchain system itself. In the case of the development, the schema is handed over to the programming group, which is distinct from the DevOps group. And the programming group will use a bunch of tools, such as HyperLedger Composer, and create the schema required for retrofitting the blockchain. And this will be terminated in a REST API, usually. And the REST API makes it easy. The REST, it exposes a REST API, which the backend of the existing applications can call. Of course, before the deployment, we have to do the testing and the usual quality assurance processes. You can do the testing directly through the REST API, or once the initial testing is okay, you can actually deploy it through the backend of the existing application. And this is very quickly the processes that go on for deploying or rather integrating blockchain with an existing application. So this is a picture of what happens behind the scenes. The application server that you see is an existing application. So whatever is to the left of it is the existing application. So there is the internet, there are some client devices. It has got its own RDBMS, which is a database in orange. The adapter and what is to the right of the dotted line is actually the blockchain part of it. I'm not getting into the details of this, but this is just to give you an idea about what goes on. So the retrofit starts with an adapter, which is code written to access the REST API, which is exposed by the Node or Go or Java layer that you see on the right-hand side of the dotted vertical line. So this is actually, in very brief, what we wanted to convey through this webinar, that the blockchain integration aims at deploying an enterprise blockchain repository for critical data of an existing application. Many applications gain additional trust and consequently save money and reduce time by foregoing some of the trust enforcement mechanisms. So even though you have to invest in the one-time cost of retrofit and the cost of setting up a blockchain instance, it may more than offset these costs by the benefits that the application derives from this process, which is both the time and cost and the transparency and the enhanced confidence and reputation that your ecosystem, it's not just one firm, but also the entire ecosystem that works with it, including the government regulators. Everybody sees that you're deploying the blockchain, and that means your reputation and confidence in you actually goes up. So there are both tangible and intangible benefits from retrofitting. So this is roughly the outline of what we wanted to convey. And any other information that you want, you can get from us by emailing the link. And we have a few minutes, about 8 minutes or so, for questions now. So one of the questions is, will you be sharing the slides? The slides will be shared, so you can please contact us if you want to get the slides. The other question is about proof of work versus proof of stake. Yeah, so the question is regarding the different varieties of the proof of stake consensus, the consensus mechanisms. Now, the open networks, because they are open, because they are anybody can enter and exit at will, have to have a higher rigor in terms of the what's called the Byzantine fault tolerance. And for this reason, the initial one had, that's Bitcoin, had proof of work, which is an incredibly inefficient from an energy perspective, but it is actually quite a effective system given Bitcoin's constraints, which is that anybody can walk in, and also there will be malicious players and people trying to subvert the system and so on. Now, given the fact that Fabric that we're talking about is permissioned, and the identification process is already there before we admit people into the system, we can take a different tack, a different strategy for the whole consensus process. So here the consensus is actually broken into multiple steps, which I briefly mentioned. And the net result is that we don't need a proof of work or similar computationally intensive consensus mechanism. So what we have currently is a very, very scalable, it is lightweight, but it provides for flexibility in terms of multiple roles, multiple participating organizations to have their own rule-based consensus, which all will be tied up together at the validation phase. So the next question is from Bharat Nair on who is responsible for the setup costs in the permission access. Now, usually one party or a group of parties have to, that is individually or jointly, invest in the infrastructure required. Now, two aspects to this. One is that what is the infrastructure required? Usually these days we use Docker containers to on the cloud to run or to create a blockchain setup, a configuration, which typically requires, depending on the kind of load that you have, maybe about 5 peers plus ordering peers and the certifying authority and so on. So this is not exceedingly expensive by today's standards, but the fact is that somebody has to pay for this, the cost of this, and usually given the fact that it is the application that you trust and not the owner, it does not really matter who the owner is. In cases where multiple parties have to jointly work together, they can all chip in into for the running cost of this. For the blockchain itself. So there is someone has to invest, and this we can make that investment as lightweight as possible by going for the cloud. But nevertheless, that cost is there. The running cost is kind of minimal, but it is the setup cost that really matters. Scroll down. Yeah, so Anil is asking the question as to what really happens to the trustless nature when you bring it on top of an existing enterprise. Is the trust of the enterprise mattering more than the trust of the blockchain? Now, this is a very core aspect of the blockchain itself. Now, irrespective of whatever the trust nature of the enterprise that owns the blockchain, whether it is an individual enterprise or a group of participating enterprises, the fact is that the blockchain has its own trust, which has nothing to do with the trust of the owning party. In an RDBMS, if an RDBMS is owned by a particular enterprise, the enterprise can, at least in concept, change the data there, because they control the super user privileges at the database level as well as the installation level. In a blockchain installation, even if somebody owns the super user privileges of that particular peer, first of all, there are multiple peers. And secondly, each peer has a cryptographic check, which makes it exceedingly difficult for a peer to, just because someone has the root password, to change anything on the blockchain. This is where the immutability of the blockchain becomes a major factor. Hold on. The next question is from Stephen Jawahar. He's asking a question: if a site like Indian Railways online booking can be rewritten using the blockchain? The answer is probably yes and no. Now, the Indian Railways site is a private site of one enterprise. And given the fact that Indian Railways owns the site and it is not, nobody else has access to the information, it does not really matter whether we use the blockchain or an RDBMS, because it is only open to them. But if you can visualize a situation where Indian Railways becomes so transparent that they can expose all their, the booking process or the data of the availability of seats and so on, if they can publicly, transparently, they want to do it, then the blockchain would be ideal. Because if you put it on the blockchain, the whole world knows that it can't be falsified. So whatever information you put on the blockchain is correct. And therefore, if transparency was the objective of Indian Railways, one of the ways they could do this is to expose their even things like availability data on the blockchain. So I think now we have to close because our time is up. And I would like to, on behalf of InApp, thank everybody who has participated. And if there are any questions we can answer, kindly email us. For any other questions that you might have about your own enterprise or your application, please email us at the address that we had provided earlier. The slides will also be shared. Please write to us if you require them. Thank you very much, and good morning, good afternoon, good evening.